Okay, continuing with our study of Taylor series and Maclaurin series, we're going to find the Maclaurin series for cosine of x. If we look back at sine of x, we had the series n goes from 0 to infinity of -1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. And as you may recall, one of the properties of series is you can take the derivative of a series and it would be equal to the derivative of the function that series represents. In this case, we know the derivative of sine is cosine. The derivative of the series, if we just take the derivative of the series definition, and we're taking the derivative with respect to x, so we get that power brought down, x to 1 less power, and that's it. Of course, we can simplify this because 2n plus 1 is the same as 2n plus 1 factorial is the same as 2n plus 1 times 2n factorial, and so the 2n plus 1's cancel, which means cosine is x to the 2n over 2n factorial. I do want to warn you to be careful about just taking the derivative and assuming that's correct. If this were a different function, we might want to look at some of the terms. For instance, if we look at sine, its terms were 1 minus x cubed over 3 factorial no, it wasn't. Sorry, I'm confusing sine and cosine. Sine is x over 1 minus x cubed over 3 factorial. You could put the factorial in the denominator for x as well. X to the 5th over 5 factorial minus x to the 7th over 7 factorial, and so on. If we take the derivative term by term, we would get 1 minus 3x squared over 3 factorial is the same as x squared over 2 factorial. Remember, 3 factorial means 3 times 2 times 1. The factors of 3 in the numerator and the denominator cancel. Likewise, with x to the 5th over 5 factorial, the derivative, the factors of 5 cancel, leaving us x to the 4th over 4 factorial. And so it does work in this case just taking the derivative of the definition of the series. So what if we change it up? What if we want the series for x times cosine x? We start with cosine x. which is the sum. N goes from 0 to infinity, -1 to the n, x to the 2n over 2n factorial. And we're going to multiply by x. We can certainly take the x that we're multiplying by, bring it inside the summation, and then use our properties of exponents and rewrite it. That is the end of the lesson. Sorry it took a little bit longer than I had for just one video. Your homework, there will be a digital copy, but it's also on Schoology as an assessment where you can just enter your answers on Schoology and submit your homework that way. Therefore, you don't need to hold on to the worksheet, but you can print it out to write on it and work on it, or just do the work in Schoology. Thank you very much. Have a great day.